Web document is that. Obviously, the good title is the key for the presentation. Before I start, today in the morning during the workshop I said I'm very interested in the language we use in IT. And part of the workshop on specification was about the language transformations. And before we go into the web page metaphor, I would like to stress how important the language that we use is and what are the consequences. And most of the time, when I talk with people about the metaphors we use, they say, oh, this is just English, this is just language, this is just terms, we just define them differently. So I'd like to start with the example from mid-17th century. So these are two covers of the books that were published just 2 years far from each other. And actually this is just a part of the cover. And actually this one as well, it's just a part. And what they present is two concepts of power. The first one is by King Charles I of England. And this is his autobiography. And this is the concept of divine right of knights. And so the king gets his power from divine entity, from God. And the other one is the cover of Thomas Hobbes' Leviathan, which is the starting point of the modern concept of social contract. And if you look closer, this picture presents the whole body of the king is built out of the citizens. This is just little people out there. And if you think about those two concepts of power, one that comes from the god and is given to the king and he's allowed to do whatever he wants, and the other one that is built from the social contract with his citizens, then I think that there's a huge difference, and the consequences to how we understand the power, how we understand the authority is completely different. This comes from the same time. The first one closes, this is autobiography of the king, and closes some period, and Leviathan is a project of the new way of building authority and power of state. So I think that I hope that these are clear metaphors, and they show us the consequences and how important it is, how we think about things we do, what concepts we use, and how we define, through which metaphors we define what we perceive and what we do. So coming back to web development. For years and years, we've been fed by the concept of separation of concerns in web technologies. We've got a content, and there's a UI, and this content we put in the structure through HTML markup. Next, we apply some presentation layer through CSS style. And finally, to distinguish it from the paper presentations, we want to use the digital means of publishing with JavaScript to make some additional features. This is clear, and like no one actually questioned this. This is like common understanding of how the separation of concerns in web technologies are built. And is it a true separation of concerns, or only this is a separation of technologies? Because if we look at the HTML, there's a lot of presentation layer of the markup already present. It's bold, it's base font, lovely marquee with a direction. And so where the boundary of the concern lies then? Is CSS only presentation, or is it presentation logic? This is actual markup with actual CSS, and this is actual output. So if you think about those two dots, why they appear not one after another, A, B, A, B, A, B, but this AA, why these guys are reverted. This is all in CSS. This is true logic. This is not just a presentation. This is presentation logic. So where's the separation of concerns? And JavaScript, come on. We've got the DOM API that gives us the ability to work hard on our structure and our styling of the document. And actually, there's no separation of concerns at all. We're gonna see it further during the presentation that it was false promise from the very early. So to understand where this concept of separation of concerns of the structure and the presentation and interaction comes from, we have to move back to the origins of World Wide Web. So this is Mac www, the browser from 1992. World Wide Web came to life in a scientific environment. And we have to understand the consequences. They worked with documents and papers, and what they were lacking was the reference that give you the next document just one click away. And the true revolution of the World Wide Web was that the reference in the scientific paper was clickable, and you could get the paper immediately. You don't have to go to the library, you don't have to order it somewhere in other institute. You just click and it's there. For that very reason, the first browsers opened all the documents in new window. Because you're reading something and there's some interesting reference. You just want to open another document and see, go through it and see if it's interesting or not. You don't want it to replace what you are actually reading. Another thing is, interesting point with the first browser ever, was that it was both reading and editing and creating documents. So the browser was to create the document and publish document and to read the document, because it was all about scientific papers connected with the links. And hyperlink is a key revolutionary point of the World Wide Web. So, what is the scientific document? We know LaTeX templates and many other templates and structured languages, and every paper, scientific paper, can be structured. There's a title, there's some section, there are some references. You can define how they are presented to the reader on the document basis, on the document level. And then, so this fits the initial goal of the World Wide Web. But then, it just spread around. So you've got a blog, but you still think of it in terms of the paper. This very first page of the blog platform, you think of it as well, just like a paper. You've got some titles, you've got some content, you've got some... So the structure is understood on the level of the whole document. This document is quite weird because this is kind of, just a few abstracts and then you go through the reference to the actual document, etc. But this is how you structure them. Unified on the whole document level. In mid-90s, the revolution came from Java and JavaScript. The difference between them was that Java was a full-blown general-purpose language that gave you the ability to program whatever you like. And through Java applets, you could embed it within the document, just like an illustration in the paper. The good thing is that it was interactive. So imagine engineering papers that are now digitally published, and now you can have those 3D models that actually you can rotate and see on the other side. This is not a paper. So this is kind of funky. You can use it very effectively in the scientific research. And JavaScript, well, it was slow, it was just a scripting language. You couldn't do as much with it as you would like. But the difference between them and why in the web development JavaScript won with Java was that Java applets were completely isolated from the document itself. JavaScript operated within the context of the document, and the consequences of this, it will take a few years to understand what are the consequences, but then this is the revolution. So AJAX gave us the ability to asynchronously communicate with the backend. So now, we don't have to think about the whole document and load it at once. We can load pieces of the content from the backend to different pieces of the web page asynchronously, isolated one from another. We still think of the web page as something unified in terms of the structure, in terms of the presentation layer, etc. But the content is split into chunks. So what are the consequences? The consequences are time of and progression of the load of content. So here you can imagine that, you can imagine that even the structure of the page is the same, even the styling of the page would be the same. You can, with AJAX, you could load different parts in different time. With the document, you have to load it at once, because this is scientific paper, you deliver it once. That's the whole thing. Now, you can say blog title and post titles, and how many comments under the post. This is the crucial thing, so we want to serve it to the user as quickly as we can. We know it now, for example, from the blogging platform Medium, that they show you just a rectangle in place where they use images. This was heavily used by e-commerce because they realized, okay, so content to user delivery time can be lowered down by just sending a chunk of information, the crucial promotions. So you get the promotions first and then other content. So this is the moment when the UX, the modern type of UX, actually is born. Now we understand that it's not only about the documents and the content we provide, this is as well about how we deliver it to the user. This opened the way to think in terms of the components. The first one is forms. With forms, what you like to have is always validation, and it was always problematic for the users that you fill in the whole big form, then you click save, and after a few seconds you get the response, sorry, some problems occurred. The form is just filled with the wrong data. So now we can think of the single form element as a separate component. It has markup, it has some styling, and it has some logic. And this logic can work on both front-end, like here with the spaces not permitted in the username here, or it can communicate with the backend without even page knowing about it. It's self-efficient. It's just isolated piece of user interface. What's more, the styling of this little component changes with the logic that is applied to it. Because the red color says that there are some errors, fix them. We've got some hints to show what kind of errors there are. So definitely both the markup and styling changes over the logic and the life cycle of the component itself. But still, if we think of how we organize the code base, we still keep this separation of, well, technologies. Concerns are common for the component, but we split it into three different words: the markup, the styling, and the logic, just because we've got three different technologies to handle those. And we've got them because it was efficient in the days of the scientific papers. So, welcome to jQuery times. jQuery taught us a really valuable lesson. And the lesson was that the workflow with the web applications was always, you start with the minimal set of the markup, with a minimal set of CSS that you present to the user. Then you've got a lot of styles that are not presented to the users, but they are there to wait when they will be useful. And then you've got a lot of JavaScript code that will make everything possible. So the thing is that it all starts with the DOM and styling. That is the seed for the JavaScript application written in jQuery that transforms it all the time. The thing is that leads us to the very subtle concept that the DOM is used for two purposes. One is to show it to the user. We show our markup and the styling, the page. And the other is that there's kind of virtual concept of the DOM, which is the input argument for the jQuery logic. So in a way, we've got two words. One is what the user sees, and the other is what kind of structure we put into jQuery code to actually transform it to something new that will seed the next jQuery iteration and present to the user. This problem has been addressed by Facebook and React library and introduction of JSX. What they changed is that, okay, so let's split it into two parts. The first one is virtual DOM. This is what we will use as an input to our JavaScript code. So we start with JavaScript and we create the virtual DOM, and then the presentation layer, the browser, is just a serialization of this virtual DOM. You can serialize it into JSON, and we do it as just snapshots. We don't test front-end as the actually rendered components. We test with snapshots. The regression is done through the JSON objects. This is virtual DOM. Just like we had in jQuery, but in jQuery it was implicit. Here it's explicit. And the actual browser rendering is, well, it's just an output. It's just a serialization method. And the browser is just a viewer for it. So now you think, okay, so we've got markup in the JavaScript, which is actually output of the JavaScript functions, and we can manage the whole interface as the huge JSON object, just with other data. We did it for years. We managed huge JSON objects in JavaScript for years. So, well, why not this one? But still, we've got some missing parts. We're missing styles, fonts, icons, images, other assets that are specific to the platform. Years ago, when you started with the web development, which you would probably install on your machine, is FileZilla. The tool that lets you send all the files to the server through FTP. Hands up who used SHTP. I mean, the thing is that these days are gone. We don't use so many script tags on the pages anymore. Now we use tools to do it for us. And the current pipeline for the front-end development is JavaScript and CSS code linting, transpiling, platform targeting, minification, bundling, cache busting. A lot of things is done through the tools like Webpack, Bubble, before actually we get the output of our application. And once again, this is just an output of the application. It's not the actual application itself. So why not to use these tools to handle the missing parts of JSX? Then we could easily think of our components as, okay, we've got a password form, so what we need for it? We need some index.jsx, which is the core of this component, and we've got some icons, and we've got these icons as fonts, because now we use fonts for icons, and we've got them for different platforms, to different font formats, and we've got some styles. And for the layout manager is a component that builds our layout on the screen. We've got some extra logic, and we've got some tests. Everything is bundled into the component. Now, let's use the tools like Webpack, etc., to handle how to bundle it and how to make it usable. But the thing is that we want to organize around chunks of user interface. We want to make those chunks composable components. So, coming back to the topic of metaphors. So, what we now have to do is to make a shift in our mental model, how we think about our web application. And it's taken from latextemplates.com. This is where the web started. This is structured documents with templates that you can just put the content into, and if your structuring markup is done well, you will get the scientific journal just with one later comment. So starting from this, we have to go into Swiftables. Little pieces of components with very clearly defined 4 interfaces on the right, left, and up and down, and that are programmable, that understand the context. As you see here, when we combine 3 of them, they understand this is a word. This is not just 3 letters. And each of them is responsible for handling just 1 letter, but aware of the context through clearly defined interface. We see it on the top pictures. So, this is a project from 2008. So this way of thinking, this mental model, is present for around 10 years now. We just didn't make the shift. We're still living in the scientific articles realm. This gives us a lot of challenges, how to design them. So what? We don't have a style for H2 and H1. How do we do it? No, we don't have it, because we've got components, and the component has its own styles. So how do we do the templating? There's a lot of questions. How do we design for it? How do we design the interface without understanding, without means to actually design the interaction between the components? How do you build the UI from components that are generic enough to understand the context and to fit into any other context? So, to make a shift and to jump into this deep pool of new opportunities, we have to use one of the go-to design advice, which is give away everything you know. Because we have to leave the mental model we used to live for more than 25 years now. And we've got all the tools are already there. But the practices, we're still waiting for the good practices, we still wait for metaphors, and we still wait for the guidelines, how to build UIs from the components.